So we've spent a long time now discussing multiple dimensions this year. And if you watched Flatland, you actually saw great explanations of some of these dimensions, like zero dimensions. We said that's a point because it has no real measurement. All a point has is location. So you can talk about where it is, but you can't talk about what size it is. One dimension, well, that's our linear dimension. Line land, they called it in the Flatland book. So there we talk about the length of something. Now, again, we can use different words to say length. We can use length. We can use distance. You can even use height. You could use width. Any of those, as long as you're measuring one length. And remember, we measure those in inches or centimeters, some sort of linear measurement. Okay. Two dimensions, we've spent a fair amount of time talking about so far. And that's where we talk about things in the plane. And when we talk about the plane, we're talking about area. Now remember that we did talk about finding in a two-dimensional space, finding linear measurements. When we did the perimeter, it's a linear measurement for a two-dimensional plane. So area is in two dimensions, so it's inches squared or centimeters squared or so forth and so on. And now three dimensions, we're talking about in a space. Okay, so that space, we now talk about measuring the volume of an object. Again, we've seen some two-dimensional measurements of a three-dimensional object. When we talked about the surface area, we're applying two-dimensional analysis to a three-dimensional object. But when we talk about volume, now we're talking about that third-dimensional analysis. Okay, so we're talking about cubic inches and cubic centimeters. So what is volume? Well, volume, just like we said in area, it was how many 1 by 1 squares fit into an area. Volume is the number of 1 by 1 by 1 cubes that fit inside a 3D object. Okay, so that's what we mean by volume. If we take a three-dimensional object like this cube here, this really big yellow cube, then when we talk about the filling it up, how many 1 by 1 by 1 cubes fit inside this? That's what we mean by volume. Surface area, we talked about how much space was on the outside of it. With the volume, we really want to know how much fits on the inside of it. So that's our difference between volume and area. And we can do it with any kind of shape. If I've got this kind of shape, that's no problem. I can easily go how much fits inside this shape. Now, when I usually talk about volume to people, most people immediately go to the first thing they learn about volume, and they'll tell me volume is length times width times height. And that's pretty simple. That's actually the way most people do look at volume. But it's not always the easiest way to think about volume. It works fine when you're dealing with rectangular solids, because in the rectangular solids, you have a length, a width, and a height. Those three things, length, width, height, are the three dimensions that we use to talk about this. And it doesn't matter how it sits, length, width, height. Okay, I can even change the name of it. I could call it depth, length, width. It doesn't matter what we call it. It's three different dimensions, and that's what we're taking a point on. So when I've got something like this, it's very easy to calculate the length, width, and height and come up with a volume. So using that basic formula of, hey, volume equals length, width, height, I can calculate the volume of this prism very quickly. So 6 times 3 times 4. Okay, so easily pull out that. Let's see, 6 times 3 times 4, and there we have 72. We're in centimeters, so the volume is cubic centimeters. So that works fine with a rectangular prism. But what if it's not rectangular? Would that work with this shape? No, because I don't have a length and a width the same way. How would it work with a triangle? I don't have that length and width. So let's investigate something a little bit. Let's talk about what actually makes volume. And I'm going to talk about it with a simple thing like a cracker. Now here I have a cracker that's an octagon. So I got an 8-sided cracker. I could find the area of this octagon. In fact, I could even trace this octagon and easily calculate the area of this flat shape. Okay, if I measured all these pieces, that's no problem. We've done that numerous times. But I don't want the area. I want volume. So if I find the area of one, and I put another one on top of it, now I have 2 of those areas together. Now I have 3 of those areas together. Now I have 4, and I have a 5th, and I have a 6th. So I've taken all those areas and put them together 6 times. What we now have is a 3-dimensional object that has volume to it. So I just need to find the area of one of these and multiply it by how many I have. Now this seems kind of obvious and a little tough to do because my crackers do have a width to them. So let's think about it in terms of liquid. Whenever I take something and fill it with water, let's say I take this triangular prism and I'm going to fill it with water. Let's get rid of that for a second. Or instead of water, because water is clear, let's fill it with something a little more quenching. Let's fill it with Gatorade. Now as I fill it, the first thing that covers is the base. So right now, I could calculate the area of the base, and with the least little bit of water in there, I could calculate that and see what that is. But as I keep putting water or Gatorade into it, I'm just adding more height. I'm taking that same base area and adding height to it until I finally get that many heights, or I get that area of the base this many times. That's the basic idea. So if I knew the area of this, I could easily calculate that. Luckily, I've done a little bit of work. I went ahead and measured that. Okay, so I measured that area. In fact, here's this triangle. And I said, there's my base. So I take that base, and it's going to be an 8mm wide base. Now, here's what I want you to do. Use what we did in the last unit. Find the area of this triangular base. Go ahead, you can do that. So hopefully you were able to find the area of this triangular base. You said, hey, yeah, I remember doing this. Equilateral triangle. So I'm going to put my right angle in there. I know that's 60 degrees. So that makes this a length of 4. And that makes my height 4 radical 3. We did that in the last unit. In fact, we've done that many, many units. So that means the area of this triangle is 1/2 base times height. So that's 1/2. My base of the triangle is 8. The height of the triangle is 4 radical 3. And that gives me 16 radical 3. So having the area of that base is going to be very important. Let's talk about why that's important, and then we'll come back to this. So here's what we end up with. Not only do we have the area of simple rectangular prisms, but we've got all these other prisms with different bases. And this formula, length times width times height, seems to work only for this. But we keep talking about the basis. Look at what length times width actually is. The length times the width is the area of the base of one of these rectangular prisms. So the volume of length, width, height really becomes the area of the base times the height. Remember that this B stands for area of the base. And this H is the height of the prism. Whoops, I ran off the screen there. Okay, so a basic formula for the area of any prism we ever deal with is the volume will equal the area of the base times the height. And I'll sometimes put a little p there to remind me that's the height of the prism. Why is that important? Well, let's go back to our Gatorade triangle. Remember that we said the area here was base times height? That's a different height. That's the height of this triangle, not the height of the prism. So now we've got a different measurement. What is the height of the prism? Well, if I measure the height of this Gatorade bottle here, or Gatorade prism, let's see, I think I measured that to be 7.5 inches earlier. I actually used this tool. And I measured that to be 7.5 millimeters, I'm sorry, not inches. So if my height, can't spell height, is 7.5 millimeters, then that means I could calculate my volume of this to be the area of the base times the height of the prism. We found the area of the base, 16 radical 3. Multiply that by 7.5, and I'll have my area. So that's 16 times 7.5 gives me 120 radical 3 cubic millimeters. That is the volume of Gatorade that I have. Now, using that, we can now apply that same idea over and over again to any particular shape. So let's take a look at one. We want to find the volume of yet another prism. Now, sometimes the key is finding those heights and all. So I'm going to try to focus this a little bit more here so you can see better. There we go. So remember, I need to figure out what the base is. Well, the base is going to be the non-parallelogram side. So my base is the triangle, and it makes a right angle here. So my height of the triangle is 9. I do need to get this measurement. 14, well, that's going to be here. So now with a little bit of Pythagorean theorem, I can find the rest. 9 squared plus b squared equals 14 squared. So I go to my calculator. Because 14 squared, I don't know. I know 9 squared is 81. 14 times 14, it's 196. I'll subtract the 81. B squared is 115, which I'm pretty sure does not break down. So we'll call that our base is 115 square rooted. So now the area of my triangle, I'm going to call that B for my base. Just remember, your base is a triangle. In fact, you may even want to say, hey, it's a triangle base. The area of the triangle is 1/2 base times height. And this is the height of the triangle. That's important to remember. So 1/2 radical 115 times 9. So that just comes out to be 9 radical 115 over 2. There's the area of the base. How do I get the volume now? Well, to get the volume, I'm going to need to do a little more, just a touch more work, because the volume is the area of the base times the height of the prism. We already know my area of the base is this ugly number here. Height of the prism, I want to find that. Here's my base of my prism. What's perpendicular? There's my height. I know it doesn't look like you want to go this way, but you've got to think I've already handled this. This was the height of the triangle. This is the height of the prism. It's at 12. So I'll multiply that by 12. So 1/2 of 12 is 6. 6 times 4 is 54. And there we go. Centimeters cubed. There is the height or the volume of that triangular prism. Doesn't matter what the shape of the base is. I just need the area of the base. And we know how to find areas. So that leads me to letting you try one. So why don't you try this figure? Find the volume of this prism. Give it a shot. Okay, so your base. What shape was your base? It's a trapezoid. So that's 1/2 the height, base 1 plus base 2. Still writing out my formulas, even though we finished that unit. 1/2, my height is the 4. My bases are 3 and 5. So 3 plus 5 is 8. 1/2 of 4 is 2. 2 times 8 is 16. So now the volume is the area of the base times the height of the prism. So the area of the base is 16. We just found that. The height of the prism, it's going to be that 7 right there. So 16 times 7. I'm going to go to my calculator for that one. 16 times 7, 917. And there we go. That is going to be cubic feet. So it's a very, very simple problem. Nothing too complicated. All we need to do is figure out what this is. Even if I went as far as going back to my crackers, all I got to do is find the area of the octagon and multiply it by the number of crackers. But wait a minute. We're only dealing with polygons here. What happens if I throw you a curve? Like a circle. I got a groan from behind me on that pun. So dealing with the circle, how do we deal with this? Well, it works the same way, because all I really need to do is think about what shape is the base. Because if I fill this circle up with the same Gatorade, I'm gonna spill all over the work. but we can see the bottom of it fills up first. Okay, and then we just keep pouring that bottom until it fills up. I'm going to go back to this because it pours easier. We just keep adding more base to it until it gets the height we want. So, a little extra Gatorade. Let's clean that off. There we go. So, for a formula for a circle, if I want to find the volume of this, well, same thing. Base, area to base, times the height. But remember, the area to base is a circle, pi r squared. So there are some people that actually just go, oh, well, if I'm doing a cylinder, it's just pi r squared times h. Only one base this time, because remember, we're actually taking that one base and multiplying it h times. Okay, so if you want to memorize this as the formula for the volume of a cylinder, you can. Or you can remember area to base times the height. So let's try that problem real quickly. Here we go. So if my base is a circle, so pi r squared. My radius is 5. So 25 pi is the area to base. The volume is the area to base times the height of the prism. So the area to base is 25 pi. The height of the prism, or in this case cylinder, is 13. Easy, not a problem. 25 times 13 equals 325 pi. No units here, so it's just cubic units. We'll just leave it alone. Easy as that. Area to base times the height. I'm going to say that so many times you're going to be hearing it in your sleep. So why don't you try one of those now? A simple, actually, before you try one, let's look at a not so simple cylinder. Now, this cylinder, it's what's called an oblique cylinder. It's no longer a right cylinder. We've been talking about right cylinders because all of our cylinders have made right angles with the circle and the sides. Okay, so we call those right cylinders. This one, we don't have that right angle. So we don't use the slanted as the height. Just like in a cone, we never use the slanted for the height. The height is right here because we want to look for that right angle. Base, height. Not using the dotted line, remember. So my base radius is only the 5, but the height is over here. I could easily slide that height over here. Doesn't matter where I measure it from. So, same idea. Base area. It's a circle, pi r squared. So therefore, the radius being 5, my base area, 25 pi. So my volume is area of the base times the height of the prism, or in this case, cylinder. So the area to base, 25 pi. The height is 15. Go to the calculator. 25 times 15, 375 pi. And in this case, it's centimeters cubed. Easy to do. So all of this is a very simple idea. Area to base times the height. As long as you can find what the area to base is, you got this. So a couple last minute questions. I want you to review what we've done today. Define volume. And then describe in your own words what the basic volume formula means. Okay? Tomorrow, we'll sit and go to class. We'll take some of these, look at some of these problems, go and investigate a little deeper, and we'll continue on. Have a good night.